Okay, so here's where we left off in the last video. We got up to this definition here, how you actually define the trig functions at arbitrary angles, okay? So theta, remember that's what the Greek letter here is. That's what this symbol is. It's the Greek letter theta. So if theta was t radians, then the trig functions at theta equal the trig functions at t as a number, okay? That equals t. It's at t as a number. And really from this definition, you can see that the way the trig functions are defined at a number and an angle are almost identical. In fact, one depends on the other. And because of that, people generally don't make a distinction between whether a certain trig function of a number is a trig function of an angle or of a number. In other words, if you see something like sine of, I don't know, theta, sine of x, sine of w, let's say, or whether w is an angle or a number, people generally don't make such a distinction. So really what I'm trying to say is actually written here. Usually from the context, it will be clear whether you're dealing with a trig function of an angle or a trig function of a number. Okay? I mean, technically there is a difference, but you can see, though, in this class, they're pretty much the same. Excuse me, not in this class. By the definition, they're pretty much the same. Okay. Also, whether our angle is in radians or degrees, you'll see, though, actually from the examples, it's really not going to make much of a difference. Mostly because in the end, you're just going to consider, the trig functions are defined using a point on a circle. Okay? Not to mention you can convert from degrees to radians. Okay, so now let's do some examples to help illustrate what I'm trying to say. So let's consider now 90 degrees, okay? So again, we have to know what the point P is going to be. Okay. So how are we going to do that? Well, let's take a look. Well, 90 degrees we know is a quarter. Oh, sorry, let me keep drawing the unit circle. Probably would be smart if I did that. All right. So for the unit circle, remember, the radius is 1. We also know that 90 degrees is 1/4 of a full rotation of 360 degrees. So we know that in standard position, the vertex is at the origin. Here's the initial side. It's on top of the positive part of the x-axis. And 90 degrees, right, the terminal side is going to be here. So this is 90 degrees. Again, it's 1/4 of 360 degrees. And that would get you back where you started. Okay, so this is our angle. So our point P would be this, over here. And what is that point? It's on that point P is, in fact, 0, 1. Okay? So the terminal side you can see here is actually on top of the positive side of the y-axis, okay? And it intersects the unit circle, so that point P here must be 0, 1. Okay, so now what about the trig functions? Well, so here we have our x is 0, y is 1, right? Remember, P is of the form x comma y. So cosine of our angle theta, which is equal to cosine of 90 degrees, and that's equal to cosine of pi over 2 radians. Okay? And by definition, that's just cosine of pi over 2. And that's equal to x. Once you know what the p is, excuse me, not x, well, it's equal to the x coordinate, which in this case is 0. So we get 0 here because it's equal to x, the x coordinate. Sine of the angle is sine of 90 degrees also. And that's equal to sine of pi over 2 radians, which is equal to sine of pi over 2. That's the y coordinate of P, which is 1, so we get 1. Okay? Again, I put x and y here That's how it was in the definition from the previous video. Okay. Now for tangent of pi over 2, right? Excuse me, of theta, just erase that. This is equal to tangent of 90 degrees, which is tangent of pi over 2, it's a lot of writing, radians. And that's tangent of pi over 2. But that's not defined because that's always that's always y over x, okay? And x is 0, so this is not defined. Secant of pi over 2, of theta, that's also not defined, okay? In other words, secant of theta, just like above, is secant of pi over 2. But again, that's 1 over x, okay? And x is 0, so this is also not defined. Okay? Cosecant is cosecant of pi over 2. Okay? And that is 1 over y, but y is 1, so we get 1. Cotangent of theta, okay? I mean, I wrote a lot up here, but you don't have to write all of this out. I was just trying to show you that whether the angle's in degrees or radians, you're going to get the same thing. It's just unfolding the definition and the fact that we're just dealing with a point on the unit circle. That's equal to cotangent of pi over 2. And that is equal to x over y, which is 0 over 1, which in this case is 0. Okay? So again, it's just unfolding the definitions.